Beautiful CNCers. I've noticed there's been lots of questions this week on the Facebook group. I don't remember all the questions, but I'm just a real world person here just playing around with the machine. I'm a CNC operator in a machine shop at aircraft manufacturer, and in fact, I'll show you. We build these airplanes right here. That's what I do. I've built a lot of these parts. I'm not an expert. I just work every day as a CNC machinist on lathes and mills. And that's one thing I want to touch on a little bit, because I've noticed I see people talking about in the mill. I have an MK2 long mill that I just recently got just to play around with. Haven't done any projects on it other than just kind of learn how some of the software works and all that. Still trying to set up a spool board. I'm gone 60 hours a week, so I'm not here. But just in the Facebook group, I see a lot of questions constantly that I wish I would have wrote down, because I want to help if I can. I'm not an expert in anything. I'm just very willing to help if someone has any questions that I can answer. I'm glad to help, and I don't want to give you any wrong information, and I won't do that for you. If I tell you something, as far as I know, it's accurate, and I feel like we can find the answer to it one way or the other. If I don't know, then I'll do some research or ask someone else, But anyway, one thing that I want you to understand, and this is definitely for beginners, and I consider myself a beginner in this woodworking stuff. So, number one, let me just tell you that I see people saying, I started my first carve. Okay, these are not wood carving machines, really. They carve wood. I'm not saying they don't. But this is a CNC milling machine, okay? So, if you see videos to do with CNC milling, to do with metal, you better watch all of that you can. Study that stuff, because Gcode is Gcode no matter what material you're using, and there's different speeds, and I understand different materials run differently, and I have no experience milling on wood. I mean, I've done plenty of woodwork with table saws and normal, building houses and different things like that. I'm not saying I've done anything. I've done a little bit of everything, but I want you to understand, number one, you have a CNC mill. If you have a long mill or, all of these other brands, I can't think of the brand names right offhand. There's good videos. Garrett makes good videos. Mark Lindsay makes good videos. Kate, whatever her name is, makes good videos. You'll run into all those people if you follow them groups. I see a lot of things that they say that I do not agree with completely. It's not terrible information, but it's the wrong information sometimes. And now, again, I'm judging from what I know about milling and lathe work, and how feed and speeds affect things. So don't always take everything you hear them say, or even me. Do your own research, and you learn for yourself. But a lot of the things they say are not accurate. I don't want to I'm not downing them. They do a really good job at educating people. I'm just saying a lot of the things I've heard all of those people say are not accurate. I promise you. So just keep that in mind. Don't take everything they say for gospel, and just do the research for yourself. So let's get into what I want you to do. This will be part one. I've already made this video 3 times, and I've had technical difficulties, and the videos are too long. Let's do a part 1 today. I'll probably do a part 1 and part 2 today, and see what questions we have, and we'll go from there. If anyone's interested in this, fine. I'm not monetized in any way on my YouTube channel, so there's nothing for me to gain. So, if you have something to comment on, leave your comments, questions especially. If you're an experienced user, you don't need to be here and watch this, because there's nothing probably nothing here for you to learn, and you're just probably going to argue with everything I have to say. So that's been my experience in the past. Anything I have something to share, I have a lot of negative comments, and people want to say, why don't you do this and why don't you do that? Remember, there's a number of ways to get something done. So let's get into this, and let me show you what I've got to say right here on part one. And I'm rambling on like I always do. But anyway, good to have you. Thanks for watching. I hope we can learn something together here. And I learn just as much as you do by doing these, because it refreshes my memory on a lot of things. So let me show you a G-code that I wrote last weekend, and even some mistakes I might have made in it. Not bad mistakes, just things to learn on. That's what's good about making mistakes, you get to learn. So I named that Learning G-code, and again, these files that you send to your machine to cut, those are your G-code files. And to open those, all you need to do is go find them wherever you save your toolpaths. Find those, like I'm looking for this one. If you want to right click and say open with, just pick Notepad. That works fine for opening G-code. You can use any word processor, Microsoft Word, a lot of anything that can look up a text file or something like that. So I'm probably going to have my glasses on, and since we've already met, let's just get my ugly face off the screen, and we'll go into this and see if we can learn something here. So at the first, I put the G codes that I believe are the most important codes that you need to learn as a new user. And for someone to say you don't need to know and understand G code, that is a scary statement. And what's weird is I've heard Garrett say that lately. In fact, let me show you this. I don't want to ramble on, but I forgot I was going to show you this. This email that I got from him the other day. His email that he sends out to everyone that signs up. I'm sure I saved that over here because I strongly disagree with this. And I've told him this in one of his comments. Nothing disrespectful to him, and I told him no offense at all, but look at what he wrote this last week. Well, September the 18th, it says, you've probably heard the term G-code in your CNC router search, but you may not know exactly what it is. And I've found that to be true for sure this week, listening to a lot of the questions being asked. But anyway, he just said, think of this as a secret code that to your CNC router. Well, there's nothing secret about it, number one. And anyway, down here, he just talks about it is the commands being sent to your CNC machine to make it move and to turn things on or off. That's really all it is. And it's not even very complicated. And I want to show you how easy it is for you to learn how to read that stuff. And anyway, he said G-code is basically a set of instructions for your CNC router that tells it exactly how to move. In a nutshell, it's the G-code that is telling your CNC machine how, when, and where to move. That's true. Now down here, he's saying, well, when you create a design and tell your design software to create a toolpath, for that design, it will create a file. That file is the G-code file. Exactly. That's what I want you to understand. Because I've had people say, what is the G-code? I don't know how to open it or anything. And I just showed you how to open it. So, but this statement I cannot agree with at all right here. He says, the good news is that is about all you need to know about G-code as a beginner or even an intermediate CNC creator. Okay, that is wrong. There's a good way to get yourself in trouble right there. And you know what is crazy about that? He made a video. Let me show you this video that he made 2 years ago. Again, this is I really believe he's doing a great job to this community and does a lot of good instruction. But I want you to remember, when people say things, just don't take everything for gospel every time. They may have a reason they want you to know something or don't know. But I'm telling you, you definitely need to know how to look at G-code and understand it. And look at this video right here that he made 2 years ago. It says top 5
CNC machines, routers, lasers, what have you. And get it.
I didn't mean to do that. This says the top 5 must-know G-codes you will use for and how to use them in your CNC. So yes, that's a really good video. I wish you'd watch that video. It's really good. And again, in his videos, there are a few things that I would strongly disagree with. And just take those for information and you figure them out for yourself. It is a really good video. 99% of everything in it I do really like, and it's good information. But remember, he said you must know these G-codes. Now that's what he said back in November of 2020. Yet last week he sent a video saying that you don't need to know anything about G-code. Okay, well I'll get to why he probably said that, but here's some of them that he's saying. G0, G1. I'm going to tell you, don't worry about G28 on that machine. It's a little bit complicated, and there are some ways that could get you in trouble. G20 and G21. Okay, I'll go over those in a minute with you, and you'll find out that G-code is really simple to understand. And the more you use it and look at it and be observant while you're running a program, you will find that it just grows on you, and it gets to where you don't even think about it. You just look there and go, oh yeah, there's that Z move right there. I need to fix that. And you can come in there and you go, I don't want that to go that deep. Or maybe I needed a little. See, I used to have that said 750, 0.750 with 3/4, and I changed it to that. And you know, that's how easy. And then you just save that file in UGS. You can save it right there and rerun it. You don't have to go back and rewrite a whole new program. It's simple as, if you see a move or a feed that you don't like, you can change that right there. Bam, you're done. So let's go through this list right here, and I've been rambling on for several minutes. So let's go. I just named this Learning G-code. Now, number 1, anything you put in parentheses in your G-code, and you can add this to the top of your G-code, or if you have some point of your G-code, usually right here at the first, you go, you know, I'm going to use some certain tool, you know, here, and you can just put that in parentheses. The machine doesn't see anything in parentheses. That's totally ignored. Even though I have G-codes inside these, the machine can't see this because it's in parentheses. Now, I want to put a startup line at the first of my G-code right here. This is a good, safe one for almost any CNC machine that you can use, and you're using it in inches now. We're in the United States here. I'm in North Texas right here, west of Dallas area. I'm about 100 miles west of Dallas. If any of you in this area, I'd be happy to meet you. Come by. I can show you anything you want to see, if I can help you there. So on this code here, let's go through the list, and then I'll show the startup code. So G0, these are 2 digits that I've got, but the last digit is the one you'll see called out a lot of times in your G-code. So G1, G0, but they're really 2-digit numbers. G0 is a rapid move. Okay, that type of move means it's going as fast as it can go in whichever direction you tell it. So just to look at a code here, this says G0, X0, Y0. That means wherever that is at this time, it's going to move to that position at wide open throttle, just like you were driving your car. And that's what he said, Garrett said in that video, is G0 is just like your floorboard in your car as fast as you can go. G0. G1 is a straight line move at a feed rate. So that's like if you set your cruise control on. Let's say you set your cruise at 55. That's a G1. That's a controlled feed rate move in a straight line. So if you'll notice in this code, it says G1 Z minus 0.750, and remember it's G1, so we got to give it a feed rate, and we put a feed rate of 50 inches a minute right here. So now we've got a straight move. It's going Z, which that's all Z can move is straight, right? It goes Z, minus, that's going straight down. Your negative is going straight down to 3/4 of an inch, and it's going at a feed rate of 50. Now, once you call G1 in your code, okay, you're in G1. You don't really have to put that in the first of every line. I like it there because I can glance at the code and I can tell exactly what move I'm about to make if I happen to be just looking at a G-code. But once you call that out and once you call a feed rate out, it's set. The only thing you need to change that for is if you want to change it to a different. So like there's another G1 line right below that one, and it's going to run it at 50 inches a minute because you already called that out right here. F is feed rate. So F50 is 50 inches a minute. That's fast, pretty fast. Now you said, man, I don't want to move this Y that fast. Well, then all you got to do is come in here and edit that and go, okay, I want that one to be at a feed rate of 20. And so that's all you do. You called that at 20. Now every G1 below that is going to be at 20. So once you call it, that's what it is until it's changed. Simple as that. And the same way, G2, G1, G2, and G3 are all kin to each other, and those are feed rate moves. G0 is on its own. It's a rapid move. So let's go up here and look at this list. So that's your rapid move. G1 is a straight line move. If you call out an X and a Y or even a Z all in one line, it's going to move all of those in a straight line. You know, there's no curves going on. It's going to be, if I said move X 3 inches, or 3 inches, but I also said move Y 3 inches and say this was 0, it's going to move that at an angle, and it's going to get to both points at the same time. Okay, that's what it's doing. So that would be a 45-degree angle if you called out both numbers the same dimension. So other than that, it's a straight line either way. It's just straight that way and not that way or that way, right? Okay, G2 is a clockwise circular motion or an arc. So if you're coming along here and you want to do a radius turn this way, around this corner, you're going to call a G2, and I'll show you how to program that in a minute so you can understand it. You're going to turn to the right as a G2 move, and you'll see I have those in here in this code where we moved around an arc. And that's a really simple thing to program. And there's a little bit of confusion on that if you look at the program, and even I don't understand it completely, mainly because I don't want to understand that. I'll show you that anyway. G3 is just the opposite. It's a counterclockwise arc. So if you're going this way, it's turning to the left. And you could keep doing those and do a complete circle. You know, so it's a counterclockwise move on G3. Now this is an important one here. Get this one. G20 is calling you out in inches. G21 is in millimeters. So we're all running in G20, most of us that are sane and still have our we're still here in the United States. We don't need to be in millimeters. We're used to seeing inches, and everything that we know is in inches in one way or another. So, you know, that's just what we're used to, and that's what we want to see. It's hard to understand people's videos that are calling everything out in millimeters because them numbers are not that familiar with us. Yes, I understand them. I know exactly what they are, but when you're calling out feed rates and other things like that, I'm not used to seeing those numbers. And a lot of the things we do in machining is numbers that we're familiar with running at a certain feed rate. A milling job I do at work all the time, I run around 15, 16 inches a minute on hardened steel, milling about 200 thousandths deep with a 3-inch face mill, and I run that at about 15 or 16 inches a minute. Now, how many millimeters per minute that is, I do not know, because I don't run in G21, I run in G20. So just remember to stay in G20 if you're running in inches. G90 is an absolute move, and this is another important one here to be sure you're calling this out in your startup code. G90 means, let's pretend this is our 0 point down here in the lower left. So wherever we call out these numbers to be, the X and the Y or whatever, it's going to move exactly from your 0 point to that point. Even if you were over here somewhere, and let's say your end mill was sitting here, your router's way over here, that's where you parked it, and you call out X 3 inches, okay, it's still going to move from there to wherever the 3-inch point is on the drawing, or wherever you set your 0 from, you know. And I like to set my 0 if I can in the lower left hand, because everything makes more sense about how many inches you're moving. And now if you need to center something up, I understand sometimes we have to use the center point as our 0, and if that case, you know, sometimes you're running 3 inches plus, 3 inches minus, you know, Y 3 inches, Y minus 3 inches. I get it, and I do that too. You know, when you want to center in your workpiece, it might be easier to do it that way, but for the sake of this training session here, I want to make it where we can see in CAD where we're at real quick and easy, and not have to do any math in our head. So that's G90. G91 is a dangerous thing to be playing around with. I wouldn't do that. I just want you to know what it is in case you see it in a Gcode, and you will on the surfacing. I think when G-Sender does that surfacing, I think it does G91 moves. And computers can do that real quick and easy because they're not as dumb as we are. But G91 is simply a relative or an incremental move, just like if you were in a drawing. Let's just say, just for instance, this is Cut 2D Pro. I want to show you the differences on that here in a little bit. But let's say if we want to move this, you know how to do that if you use Vectric software. So we're going to go move this. And let's keep it down here in the lower left since that's what we're doing. See, right now it's showing it's in the absolute position right here at 0 X and 0 Y. Right? Now if we do a relative move, well, first off, let's just move this somewhere else. Let's move it at 3 inches in both directions. All right. Now that's an absolute move. It wouldn't even have mattered if that was over here. If I put in that number, it's going to be right there at the same place. Either way. So now then, I got to select the. If I was to tell that to move, I'll show you the difference. So if I set an absolute move of 3, which I just did, it's kind of hard when we started at 0. In fact, just for the fun of it, let me move. I'm going to move this just with the cursors, just some bogus numbers. See those goofy numbers that are set up right now? Now, in relative, see that turns to 0. So that means any moves that I make in relative, G91, remember, over here in our code, the G91 is an incremental or relative move. See, this says relative. So let's just say I want to move this, well, I hate to say 0. Let's just say I want to move it minus 3.0 inches in both directions. Okay. This is in a relative. That'd be like if you called a G91 out. Okay, it moved there. Now let's undo that. See, that was a relative move. Now Control Z that. Now let's do an absolute and do that same move. And you'll notice it's not in the same place. Let's do minus 3.0 and minus 3.0. Bang. Now we're down here. So you see how you can get in bad trouble if you use that in a G-code. And the only real reason to do that, I think, would probably be if you was, say, drilling a bunch of holes, for instance. So let's just put a hole right here. And let's say, let's put an extra hole right there just so we can play with it. So Now let's say I want to drill that hole every inch, 1 inch apart, so I could actually go in the G-code and say, no matter where I'm at in the drawing, I might have started that at a 1/2 inch here or 3/8 of an inch at the edge, wherever. I don't even know where this is. This is at X 14.992. So it doesn't matter if I call that a relative move, and I say I want this 1 inch in relative, then it's going to move it 1 inch, right? So that's the point of that, is you can just call something out every inch or so, and you could have a program to just go, G01 1 inch. Then all you got to do is call in X1, 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 and it'll keep moving 1 inch every time. And then you have to call G. If you do that, you're going to have. Let me get rid of all this. The dangerous part about that in a G-code is if you did that, you got to be sure that you come back in that line and change it back to G90, or you're going to crash and go crazy, or something's not going to be in the right place. So it's best to not even use G91, honestly, because you can get yourself in trouble. And it's just adding extra work. If you could just figure out what move you want to make, just leave it in G90 and move to that exact position, and that's fine. All right, so we covered all these G codes that I feel like are pretty important to know and understand. And so M code is, G code, remember, was just movements that the machine's going to make. That's all it is. It's how the machine's going to move. M codes is to turn something on or off. So M3 is to turn the spindle on. We don't have spindles, most of us. We're using routers that we flip a switch and turn them on. So we're not going to worry about that for right now, but it doesn't hurt for it to be in the code. I notice it's in the G code a lot of times on like here's one that Vectric made, and they call out tool 1, which we don't use tool numbers either because we don't have a tool changer. That's for automatic tool changing or something like that. And G17, I didn't go over that yet, did I? Forgot to put that in the list. G17 means you're in an X and Y coordinate, so you need to call that out, because like a lathe works in an X and a Z coordinate. That's how a lathe works. So G18 would be a lathe, but G17 is for most milling operations. That is a vertical mill, like we're using. Horizontal mill might be different. G20 is in inches. We've already discussed that. So see, they're calling their startup code out like this. G90 is absolute mode, like we just talked about. And so that's what they call out. And while we're in here, I'll show you that at the bottom of their code, they usually put an M2, which is very uncommon. M30 is what most people use. All that means is it's going to end the program. And M5 here, if you see that, is to turn off the spindle. Which again, we're not doing. It doesn't hurt it to be there, but we don't turn our spindles on or off unless we have a add-on spindle that we've put on. And then we will, but this is for the beginning MK2, just like you get them with no spindle. So let's go back to the code that I was going over. So I don't know why I didn't put G17 in here, and let me write that in here while we're in here, because that one is, I'm sure the mill already has all these set in it automatically, just in case. It's just, oh, I don't need it there. This is just working. I'm trying to use capital letters to make it easier to see this. We're working in X and Y coordinates, I think you call it. I don't know how you spell coordinates. Maybe. So that's the moves we're going to be making. They're all in X and Y, and I guess they don't include Z in that. But just for the sake of where your positions are, that router's moving around too. It's in the X and Y position. Let's put us a space in here so G-codes move the machine around. M-codes just turn something on or off. So M3 is to turn the spindle on clockwise. If you, some rare reason that you had a left-hand cutter, you would turn that on with M4 if you were turning a spindle on. M04 would turn it counterclockwise. And in this case, we're not using coolant, but if we're using a regular metal milling machine or lathe, M8 turns coolant on and M9 would turn the coolant off. And like I just said, M2 ends the program like Vectric uses, and everyone else uses M30, ends the program and rewinds. You can use either one of these. I like M30. It's just the most, I've never heard of anybody using M2 before I saw that come up in this Vectric software. So, all right, that's enough studying on G-code. I would suggest that you just go Google or find you a copy or ask me and I'll print this up for you if you want a file of it, or you can just type your own file. But that's your most common ones that you're going to see in G-code. And how long is this video already? It's ridiculous, 30 minutes already. So let's call this part 1, and let's get into some G-code, and let me show you in the CAD program a little more about how the G-code works when you see it and how to understand what it's doing, and so you can edit it, and also I want to go over some post-processors that I heard some people being a little confused about what post-processor to use. And again, I'm no expert. I'm just showing you real-world stuff here of just kind of how I do and how I've figured things out over the last, some of it several years ago, some of it recently I've learned. So, and we're learning every day. I like to learn more and more about this. So appreciate you hanging with me here, and let's call this part 1, and we'll see you in a little while on part 2. Thank you very much for watching.